Okay. Hi everyone, welcome back to the Stop Wonders, the podcast where we explore the innovation shaping our worlds. I'm your host, Alex, and today we're diving into the fascinating work behind one of the greatest technological achievements in modern communication, fiber optic cables. You make the story begins in 1840 when a Swiss physicist named Daniel Holland first demonstrated that light could travel through water using total infinite propulsion. It was medical like blending and bouncing its way through a stream of water. The principal was one can call the foundation of fiber so far. The 1930s, scientists were experimenting with gas to create light in dark plants. They didn't know it then, but they were setting the stage for something revol- revolutionary. And the gas became 1966 carries all often called the father of fiber optic made a groundbreaking discovery. Proposed that they on travel long distance from 45 plus fiber. At that time, the idea was almost log heavy, plus as transmission medium wide would co-benefit unified in the science so that with minimal impurities plus fiber could transmit light signals without massive loss. It was like discovering a superhighway for light image tracking all the information in the world and sending it at the speed of well like uh, the fish. vertical fiber optic cable with development in the 1970s, mostly for medical use in industries, but some telecom companies realized this once used and so it was revolutionary. Um, the, by the 1980s, companies like AT&T began laying fiber networks, submarine fiber optic cable were laid across the Atlantic in the 1990s. The world became quiet and fast. Today, in more 99% of global data travels through this tiny glass third. Think about it a single strand of fiber thinner than a human hair and carry terabits and terabits and data per second. And how it's made. So how do we make these mackerel cables? It's a start with poor silica manufacturers had it out to offer 1,900 degrees Celsius to form the forms. Can parts of ultra-pure gas is then drawn into these tons, often kilometers long, in a process called fiber drawing. The fiber is coated to protect it from moisture and physical damage. Then it's bundled, tested, and shipped off to become part of the global internet highway. And inside, like pulses turning on and off billions of times and scan encoding the data we use every day. Fiber optic has already transformed the world where just getting started. Engineering are developing multi-core fibers that can carry even more data, sense things, and experimenting with quantum communication over fiber and sound fiber might connect every home and business on Earth. No more buffering ever. So next time you send a message, stream a move, or listen to a podcast like this one, remember the journey that music took from light to glass to your device. And this is closing segment and that wrap on today's episode of Testing Wonders. We hope you enjoy this journey into the lightspeed world of fiber optic. If you learn something new, don't forget to follow us. God Okay, until the next time, keep your coffee alive and I and this is my podcast with Jimmy.
Hi everyone, welcome back to the Stock Weekly. I'm Alex.
And I'm Jamie. In today's episode, we are diving into the fascinating world of fiber optic cables, how they're made, and why they're revolutionizing communication.
That's right, fiber optic have transformed how we connect, whether it's high-speed internet, telecommunication, or even medical device.
And to understand their impact, we first need to look at how they're made. So let's break it down step by step.
Before we jump into the production process, let's define what fiber optic cables actually are.
Good, uh, good idea. I a fiber optic cable is made of thin strand of glass or plastic that transmit data as light pulses its way faster and more efficient than traditional copper cables.
Actually, unlike copper wires that use electrical signal, fiber optic really on light, which means less surface and higher speed over long distance.
Plus, they're super lightweight and more durable against environmental factor.
Okay, now that we know what fiber optic are, let's talk about how they are made.
The process starts with making something called, called a glass perform, which
Right,
is essentially a thick glass rod that will later be drawn into thin fibers.
this perform is made using high purity silicon dioxide and other chemical compounds to achieve the desired optical properties.
The most common method for making a perform is called the modified chemical, chemical vapor deposition or MCVD.
Here's how it works. A special latch attaches a glass tower while gases like silicon, textured hold and oxygen are introduced inside inside the latch and deposit layer of ultra pure glass.
The result, a solid glass rod that has the same refractive index structure as the final fiber optic strand.
Now that we have the glass performed, it's time for the next step.
This is where the magic happens. The perform is heated to about 200 degrees Celsius in a furnace, making it soft enough to be stretched into long, thin strands.
Are pulled downwards continuously to form fiber with a diameter of about wide with a diameter of about 125 micron, that thinner than a human hair.
That's crazy. That's crazy. And the best part, and the best part, the fibers, thickness, and optical properties are constantly monitored using laser to ensure precision.
Once the fiber is drawn, it moves to the next stage, coating and striking.
Science raw fiber is fragile. Fragile. It needs protection. Right after being drawn, the fiber is coated with a layer of polymer to shield it from moisture and physical damage.
These coatings are formed using UV light, making them tough yet flexible. This ensures the fiber can handle bang and strike without breaking.
Without this step, the fiber would be too delicate for real-world use.
Actually, now let's talk about how multi fiber are built together into a cable.
Once the fibers are coated, they are grouped into bundles and wrapped with protective layers.
Depending on the use case, a fiber optic cable might have multiple layer, including water-blocking glass, strands, members, and an outer jacket for durability.
Some cables are designed for underground installation, while others are used in buildings or even under the ocean.
That's that's true. Undersea fiber optic cable from example have extra productive, eh, extra and protective layers to withstand extreme conditions.
Now that the cables are ready, they go through rigorous testing to check for signal loss, strain, and durability.
The tests ensure that cable can handle real-world data transmission with minimal invest.
Once they pass, they're shipped to telecom companies, internet providers, and industries worldwide.
And that's how we get super fast internet and global communication.
Wow, that was a lot of information. Fiber optic truly are an engineering marvel.
Absolutely, it's amazing to think that something as small as a strand of fiber can power our entire digital world.
If you enjoyed this episode, don't forget to subscribe and share it with your friends.
Thanks for tuning in to Tech Talk locally, and we'll see you in the next episode.
Bye everyone.